Every year, the National Science Day is observed on the 28th of February, and the theme for this year's observation is Science and Technology for Sustainable Future. In Shillong, the National Science Day was observed at the Survey of India, in which a science exhibition was held wherein various schools from in and around the city took part enthusiastically.
Every year on 28th of February, it is celebrated throughout the country to commemorate the discovery known as the Raman effect, which was discovered by an Indian scientist, Dr. C.V. Raman, way back in 1938. And 2 years later, the Nobel Prize was awarded to him sometime in 1940s. So to remember this day, since the year 1986, the government of India instituted the celebration of National Science Day. On an occasion like this, the institutes under the Department of Science, Technology, and also other government departments, they popularize science through exhibitions. They popularize science through one is exhibitions, then quiz, public debates, then radio talks, shows, and so on. So these are various media through which the National Science Day, the observance of the National Science Day is propagated throughout the country. The theme for this year is very, very relevant because it talks about sustainable future. So science and technology for sustainable future. And it is the endeavor of the government, central as well as the states, whereby they would like to incorporate the environmental concerns in the planning process itself, so that its adverse impact on the environment is nullified at the planning stage itself. So on that score, when we have the National Environment Policy 2006, we have the National Forest Policy, and so on. So in all this, the mandate is to see that the country develops by ensuring that the environment, forest and wildlife of the country is preserved, it is conserved for the future generations. I have gone through the display of survey equipments which are currently in use by Survey of India, and then the exhibits of the maps right from the inception as early as 1860s. This institution is more than 250 years old, and it has that glorious history of the map making in the country, and we all look up to Survey of India. Say even for the reserve forest maps of India, all the notifications was based on the survey map which was conducted, which was plotted by the Survey of India as early as 1860s, 1920s, and so on, and even till today. So I commend the yeoman's service of the Survey of India for the cartographic map which they have plotted for the entire country, covering various aspects of the landscape, including forest, the apart from the administrative boundaries and so on. And I'm sure that with their with the technical expertise which the Survey of India has, I believe that our boundaries, the securing our boundaries through the maps which they produce, they are in very, very safe hands, and with sound technical knowledge which they are providing to the country.
The geography is very important, and the location constitute almost 90% of the data created all over the world. If you know your location, you can plan so many things. And thanks to the Google, the map was very unknown to many of the people of this country. Now kids are using Google Maps, and they at least understand map is something they can plan over it. In Survey of India, we are celebrating this Science Day, and we are exhibiting the different methodology, how the maps are being prepared, what is the use of these maps, and how one can utilize those maps in their general planning. So when we are talking of this location intelligence play a very important role, because if you know your location and if you know the location of different things, it is very easy to make decisions. Because if map is not there, there is a limitation how much you can see. But with the aid of map, you can see a large area, and in relation you can see the different features, and based on those features, the constraint and the availability, you can make informed decisions. So kids are coming in from different schools in our campus, and today, as our chief guest said, we are demystifying how the map is being formed, how the map is being prepared. It's a very specialized science, and as you see, it is not easy to create, because it has to give the value which is correct on the ground. We cannot sketch anything and we can call it as a map. So for map, we need accurate locations, and for that modern technology gives us latest instrument. Those instruments are being displayed in our campus, and students are coming and getting knowledge how these instruments are working, and based on that they can have the inclination of coaching in this field. Because what is happening, that now surveying and mapping is being so specialized that lot of computer knowledge is required. And the irony is that the computer science graduates of this country or any country do not understand it as a main field. They are going to different domains, and we need badly those computer engineers for the development of the map making and for the development of the information science. So when a student will involve at this tender age, and they will understand the beauty of those things, they got the inspiration to enter in this domain, and that will go a long way to help the country in preparation of this geoinformation technology, geoinformation maps, and utilize them for the better decision making.
Geography is one of the subject which they study in the school. And as per the syllabus, whatever I could see, whether it is CBSE syllabus or the MBO syllabus, they have a chapter on map reading, on map making, etc. Now the exposure which the students will get today as they go through the exhibits here, that will give them a visual representation of how the maps are actually being plotted, the methods, the flow charts, all these which probably will not be available in their textbook, but here in the Survey of India, all these methods, whether it is conventional method, whether it is a digital method, all these methods are clearly shown on the flow chart or on the chart, and this definitely will open their eyes to understand better how the maps are being made today through different methods.
Control segments, those segments, in control segments we have master control stations, monitor stations, like that. From these stations, they are controlling all the satellites. We are in user segment. In user segment, what we have? We have one antenna, okay, and another thing, you have one receiver. This is receiver, okay. This is receiver, and this is recon. So what are the components? This is antenna, receiver, and recon. Okay, these are the components in user segment. Yeah. So in user segment, we are using also this one. This is handle GPS. Okay, we are using this one. This one high precision GPS. This is dual frequency. Okay, this GPS you cannot take here and there. Okay, it is used only map making. And this is handle GPS. Handle GPS you can take and move around all the campus. Okay, and you search the position. So this is handle GPS. And now how this instrument give the position of this satellite, or of this how this gives this position by GPS, this position. So how to calculate? No, calculate means for getting the position of this, getting the coordinate of this position, we need 4 satellites minimum. How many satellite signal? 4 satellite signal you need in sky. Okay, so 4 satellite, from 4 satellite they emit some radio signal. What is the velocity of light? 3 into 10 to the power 8 meter per second square. Yes or no? So that is the speed, meter per second. That is the speed. In that speed, radio signal is coming to this antenna. Okay, from the satellite. That is the time. Okay, that is the velocity. Velocity is 3 into 10 to the power 8 meter per second. And one clock is in satellite. That is atomic clock. That is not a general clock, not hours. Okay, that is atomic clock in satellite. And one clock is here. That is in receiver. Receiver one clock, that is very small. That is called oscillating clock. Okay, and that is atomic clock. Signal is coming from there to this antenna with what velocity? 10 to the power 8 meter per second with the velocity of light. Okay, that is coming to the antenna and going to the receiver. That is different thing. Receiver is storing the data. How many satellites, what are the satellites coming in signal, like that. Okay.
The GIS information you will be getting directly. So this is a very good way, direct way of producing DTDB. So it facilitates it. It is very much connecting with remote sensing and geographical information.
This is called DPWS, Digital Photogrammetric Workstation. So this is monitor, LED monitor, 22 inch. Then this is LCS glass, liquid crystal shutter glass. This is Topo mouse. It contains 16 buttons. And this is CPU. Okay, so we have put some photograph of Durgapur, West Bengal. We have digitized this. Some of our features like road, then nala, stream. Okay, some buildings, some pond is there. So you can view one by one. This all the 3D. Okay, this view. Yes. Now you put inside this. This view 3D. Now you tell me.
The greatest advantage is this, that we can, without going to the ground,
Cost effective it is.
without going to the ground, we can
Produce digital maps. Just see. Here one culvert is there. Can you see? Yes. One more you can put. You can take. Anyone you take. So see some culvert, some river is there. Okay. Some roads are there. So straight away you can digitize all this and produce topographic maps. Yes, you've seen. See some buildings you can see. See building. Okay. Okay. So all this, so ultimately we'll get a topographic map.
Now, what is digitization of a map? Digitization is a process of converting analog or graphical data to digital data in a computer readable format. For that, the process involves scanning of the map, scanning of the hard copy. Once scanning is done, we have to go for creation of projection. Now projection, what is a projection? Projection is a method of converting three-dimensional earth surface to a two-dimensional surface of paper. Once projection is created, we have to go for warping of the map. The map which is already, the hard copy of the map which is already scanned, I have to warp it. So for that I am going to do it using MicroStation V8 software. Let me tell you how to create a projection of Shillong. Now to create a projection, we have to fit some parameters. This particular sheet will have its own parameters such as maximum, minimum, latitude, longitude values. These are already fed. Okay, then some more parameters that we need to feed are what is the kind of projection I'm going to use, then what datum I'm going to use. After feeding all this, I can generate the projection. Once projection is created, next step is warping of the data, warping of the scanned data. That's scanning. So I'm going to warp it using this MicroStation V8. There is a tool called warp. Okay. Now what you need to do is, warping is nothing but aligning the scanned data with the alignment of the projection. We also call it georeferencing.
It is very interesting. It's the first time I'm coming to survey, getting to know about it. I had been having an interest, like how did people develop maps, but now it's all cleared. And this is a very nice experience, coming with friends and getting to know. And then this is a very nice interaction about prisons, and then knowing the scales of the places. This will help us more as we are in 9, so this is giving us a good indication, telling us more. So in some way it is a really nice experience and we're having fun, getting to learn new things. Like we knew the use of prison, that gave us only spectrum, but now looking at this, now we can even have surveys with prison. So it is a new way we are learning. Thinking about the scales also, it is telling us the scales. We thought the scales were very small, but looking here it's like 1:50 millions. There are many scales, there's so many different types of scales we have seen. So it is very interesting. We are roaming around here and knowing more things.
The great trigonometric series spanning the country from north to south, east to west, are some of the best geodetic control series available in the world. Now the vision of Survey of India. Survey of India takes a leadership role in providing user-focused, cost-effective, reliable and quality geospatial data, information and intelligence for meeting the needs of national security, sustainable national development and new information markets. Now what is the mission of Survey of India? The mission of Survey of India dedicates itself to the advancement of theory, practice, collection and applications of geospatial data and promotes an active exchange of information, ideas and technological innovations amongst the data producers and users who will get access to such data of highest possible resolution at an affordable cost in the real-time environment. Now, since Survey of India is a national mapping agency, so we have a mandate. It acts as an advisor to Government of India on all survey matters. It provides geodetic survey, including control work, geophysical surveys, and tidal observations. We do topographical surveys and mapping within India on different scales. We handle all the matters concerning international boundary. The unit in Shillong handles the international boundary between India and Bhutan and India and Myanmar. We do surveys for developmental projects. We do cantonment, large-scale city surveys, and guide maps. Publication of geographical maps and aeronautical charts. These are used by the pilots. And we do some special series maps also. Now, as a national mapping agency, we need to create a national spatial reference framework. We need to create a national digital elevation model. We create a national topographical template. We create administrative boundaries such as district boundaries, state boundaries, and toponymy. Toponymy is place, name of place, like Shillong. So this name is given by Survey of India only. Until unless Shillong, the word is verified by Survey of India, it is not considered official. Now the services which Survey of India provide. We do some geodetic survey. We do geomagnetic surveys. We do gravity surveys. We find out the value of gravity, G. Satellite geodesy, including GPS observations and tidal observations. Now we do some topographic surveys, which includes topographical surveys on various scales. As the maps you saw, these all maps are on different scale. So as per the user, some users require a small scale map, some user requires a large scale map. So as per the user, we give topographical maps. We do some project surveys and expeditions. This is a diagram giving a brief of high precision leveling network which we have created all across the India. Now, geomagnetic surveys. We have a specialized wing in Sabhawala, and you can see some photographs. These are the equipments which we use over there, and then we create such kind of geomagnetic charts. These lines are lines having equal declination. Then tidal observations. Survey of India has been carrying out tidal observations for more than 125 years. We publish tide tables every year, and now with the advancement of technology, now we are able to provide the tide tables on a real-time basis. These tide tables are useful for finding out
Yes, we got an individual. Earlier we used to do lot of calculation, and we are using precise HMI also.
India, as it is known today, is witness to the astounding adventure of gigantic personalities who took upon them the mammoth task of mapping the entire subcontinent. Rightly hailed as the most stupendous works in the history of science, the Great Arc, or more popularly known as the Great Indian Arc of the Meridian, is the amazing saga of human endeavor. A scientific undertaking of Herculean proportions, the Great Indian Arc of the Meridian began in the first half of the 19th century, from Cape Comorin in the south to the foothills of the Himalayas. Taking thousands of lives and costing millions of pounds over 5 decades, this was at that time the biggest scientific project ever undertaken. The surveyors used hills or temples or even specially built towers as observation points. They cleared jungles and leveled the hilltops and villages, only to create a line of sight. They did not give up in times of deadly diseases, attacks by tigers and elephants, and of course, their human enemies. And yet, the results were commensurate. The Great Arc did not only involve the mapping of the Indian subcontinent, but it made it possible to establish the accurate measurement of the Himalayas. More important still, by producing new values of the curvature of the Earth's surface, the Arc helped in significantly advancing the knowledge of the exact shape of the Earth. But how were these measurements done 200 years ago? How did these men, from an era before GPSs, satellites and barometers, map an entire country along with the height of the world's highest mountain? Join us as we resurrect the entire epic tale for you tonight. (1799) Mysore. The British and Nizam have joined hands to take over the kingdom of Mysore from under the swords of Tipu Sultan. Today, River Kaveri is at its lowest level. The assault is to begin at 1 p.m. The kingdom of Mysore awaits its destiny. Wellesley wanted maps, but Lambton, who was obsessed with calculating the exact size and shape of the Earth, saw this as a golden opportunity. Lambton's proposal was a meridional arc in India, an arc which would be the longest, the most accurate, and the first in the tropical latitudes. Who knew that the obsession of one man would incite one of the world's greatest discoveries, the Great Arc? About the size of a small tractor and weighing half a ton, theodolites measured angles between different bearings. But only 2 or 3 of these boasted of precision and were accurate. One such theodolite was specially commissioned from the Carry of England by William Lambton. But as destiny would have it, the ship carrying Lambton's dream was captured by the French before it could ever reach the Indian soil. 57 days passed by. 400 men and women toiled relentlessly in the southern sun. A 100-foot-long chain was used for measurement, and 400 such measurements had to be done separately. This was how the first baseline at Marina Beach came into being. The French respected science. In fact, geodesy was a national passion. When they realized the cargo of the captured ship contained instrumentation and not artillery, they repacked the theodolite and released the ship with a congratulatory letter to the government of Madras, which reached Lambton. The great chase had begun. Lambton spent the next 6 weeks repairing the instrument inch by inch in his tent. He was aware that this may lead to errors in measurement. But fate seemed to side with Lambton for once. The differences were but negligible. And this is how Lambton measured the longest geodetic arc, closest to the equator, from Cape Comorin to the 18th parallel. (1822). 2 decades have passed, and half of India is still waiting to be mapped. When Lambton went to sleep that night, he never woke up again. The responsibility of taking the great trigonometrical survey of India to its conclusion in Agra descended unexpectedly upon George Everest. It was 400 miles before the greatest arc could be mapped. These 400 miles went across the plains of Ganges. The land was mostly flat. Thus, in the absence of hills, Everest built masonry towers over 60 feet high. The towers once built could not be moved. Some of them are seen even today in various parts of India. By 1833, Everest moved his headquarters to Dehradun, where today the Survey of India building stands proud. Indians were known for their tradition in mathematics and engineering. This led to the appointment of Radhanath Sikdar as the chief computer. Among the snow-capped peaks of Himalayas, Peak 15 particularly interested Sikdar. After 4 long and arduous years of unscrambling mathematical data, he became the first person to identify it as the world's highest peak, the Mount Everest. On 27th June 2004, an Indian postage stamp was issued commemorating the Great Trigonometrical Survey, featuring Nayan Singh and Radhanath Sikdar. This is the boundary where stands the story of such people who, with their undying spirit, created history. In a country with plurality of social, linguistic, religious and regional identities, a single measurement and a standard map gave a definition to the notion of India, the India of this day.